my name's Sean Farmar, and I'm going to speak about lessons learned from my experience with service-oriented architecture. Today, it's a bad word, right? Today, the buzzword is microservices, and we're all about doing microservices, and SOA is so old and enterprisey, and it's the wrong thing. We're doing mistakes over there. However, in our industry, we love to reinvent the wheel. We give it a different flavor, a different brand, and we just try to do it again and again. Doing it differently, of course, and however, we seem, at least in this kind of cycle, I'm quite sure that we're repeating all the bad mistakes that we've done with the beginning, when we started service-oriented architecture. Not me, of course, but people started service-oriented architecture about 10, 15 years ago. So I'm going to try and share my experience and hopefully give you a couple of pointers, and maybe you can do it better than I did it when I started. I have nothing against microservices. It's not like I'm against it or anything like that. I just think that there's a lot to learn from the past, and I see a lot of microservices implementations that are having difficulties, and it's a shame because we could have avoided that. Who in the room here is actually doing microservices in production? Yeah, like a good portion of the room. Who is starting a microservices project now? Who's planning? Very few. All right. So I'm hoping that it's going to be valuable for you. I'm going to start with my own little story. About, I don't know, 15 years ago, I was doing software for the good bit of 10 years. And I did small projects, big projects, web, backends, all kind of things. And we always ended up in the same place. So even if I wasn't on the team that actually managed to kind of get to the point where it was breaking, I was either handed a project that was already at the big ball of mud thing, or I was building a big ball of mud, well-designed, properly designed, all good practices. And from the day we deployed it, it headed towards this this end point where it's going to be like that non-maintainable big blob of software that's going to fail in 2-3 years. As soon as we deployed it to production, and as soon as we did the first cycle of more features or even small improvements, we're heading for the wall. You knew it immediately. And I really tried everything, based on Microsoft best practices. And I tried layers and tiers. I tried service layers and layers for services. And then I even tried distributing monoliths using web services. Yeah, so I had like a couple of monoliths, each kind of in its own domain, and they were talking to each other with web services. Anybody try that? It sounds very similar to what we do. I hear people doing today with microservices, where they have RESTful services. It sounds so cool, but at the end of the day, it is exactly the same idea. There's synchronous communication between different components that once one of those components fail, what happens? Everything fails. Very slowly or very quickly, it depends how you manage to build it. But it's just a recipe for disaster. So I was really, really frustrated. I went to my master and said, Master, Yoda, won't you tell me what am I doing wrong? I'm really, really trying hard. I'm really going, but every time I end up in the same place. Einstein said something very funny about that. So Yoda came back to me and said, coupling, your problem is, as if I didn't know it, right? But Yoda being Yoda means that now you have to retrospect whatever he says and really take it to heart. So I said, yeah, no problem, decouple everything. So before we go on to decouple everything, let's talk about what is coupling. Coupling is kind of the two big aspects of coupling is what you depend on and what depends on you. The more of those dependencies exist, the worse your coupling is. Obviously, if you fail, then your dependents fail. If other of your dependencies fail, you will fail. The longer that tree, the bigger that tree, the more dependencies there are, the worse coupling is going to, you know, hurt us. Of course, to flip that, there is no way to build a system that has no dependencies, right? Otherwise, it's one single process singing, working on a laptop or a single computer, right? Like Word, Excel, yeah, something like that. That probably has, you know, its own dependencies, its own subdomain, will never interact with anything. Not today, of course, with the web and everything, but... So let's look at the different aspects of coupling. We have the temporal coupling, and this is all about, or temporal coupling, sorry, which is all about time. It's about, you know, something starts at one side of the process. The more this coupling is long or has more I/O or has anything to slow the processing, that temporal coupling will get us to have a lot more performance issues and a lot more communication issues. There's also logical temporal coupling, which means that, you know, although the process itself is finished, we can't do the next step before we finish one thing, and we can then start another process. So even if we technically decoupled stuff, we still have this logical synchronous, this procedural programming style, yeah? Where we go and, you know, we create the user, then we send him an email, then we go and submit, you know, commit something to the database, then we do another operation, another operation, and although we can distribute those 5 or 6 operations, one can't happen without the other. Does that make sense? The other aspect of coupling is physical, where, you know, we are, you know, who didn't write the connection string in their code? Didn't. Yeah, okay, no saints in the room. That's good. So we all did that kind of, you know, we hard-coded our connection string. We deploy to servers and use IPs instead of names. The endpoint address is hard-coded into something. There is no capability of being able to decouple those kind of where we put stuff. Obviously, special coupling would be required many times because we want to deploy application close to the database. We want to deploy a cluster of close services, also physically close together. So that's another aspect we need to look at. The last one is platform, and platform is a lot less of a problem today because we all live in this world where we can, you know, mix Java, you know, Linux and Windows and use multiple languages and cut across boundaries of systems. But in the old world, it was, you know, very, very difficult. Anybody did .NET remoting here? A couple, okay. .NET remoting was this thing that enabled you to call one Windows computer to another computer and execute a remote procedural call, yeah? And that was obviously didn't go across platforms and all that. So, and the point is that between all those things, once we start, you know, exiting our single app domain, we have a network, right? We have this thing that we need to cross and to talk to the database or we need to talk to a web service, and we do that in our style today even, and in the way we code, we ignore the network altogether. Anybody does this kind of thing, yeah? We new up a proxy, and we go, oh, and then just next line, we use the proxy, right? Did anybody have any checks here in the middle to see if the proxy exists or if it's available? And what do you do when this thing throws an exception? Anyone? Retry. Who did retries? Who did retries, really? Yeah, that's very advanced, yeah? Because most people just, what did they do here? What do we do? Throw an exception and log, right? And what do we do with that? Nothing, yeah, right? If we're lucky, we have some monitoring. Otherwise, this piece of data here that we just passed, the $1 million order, just went down the drain, right? Blew into the ether, and we'll never be able to come back to it. And advanced, I guess now with microservices, I see a lot of people doing retry mechanisms by saving the data first, then trying to make the call, and then coming back and checking it, right? Yeah? Anybody does that? Store the data before they... Does that sound like something like messaging? Do you do messaging? Messaging, anyone? Yeah. So if we code like that, we are setting ourselves up to failure. And now, 20 years ago or more, people were looking at this thing and saying, and these are smart people in what was Sun Microsystems and other places where they were building networks, and they said there are patterns here that people are simply ignoring the network and ignoring the fact that distributed systems we need to cater for the fact that we're crossing the network. Those were coined the fallacies of distributed computing. So if you are doing distributed computing, and most of us are doing distributed computing because we cross the boundaries of a single machine, then we need to think about those fallacies as if they're true, right? So anybody here thinks that the network is reliable? Luckily, I had to send you. Not at all. And latency is 0, the bandwidth is infinite. The network is secure, right? Once we are on the network, nothing is secure, right? The best secure computer is disconnected from the network, turned off, and under 10 centimeters of concrete, right? That is secure, maybe. Topology doesn't change, and in today's world, it's ridiculous to say that, right? But 20 years ago, it was an issue. People would just ignore the fact. And there's one administrator. Anybody is in our DevOps world, we all are our own administrators, right? Transport cost is 0 again, and network is homogeneous, and that goes on and on. But I'm not going to kind of waste your time and talk about it. You can kind of follow that link and download an ebook that has a really nice story, really funny, really cool, and go to Ted Newell's blog where he talks about the next fallacies. He coined 3 more. One of them is business logic should be centralized. Yeah? Do you like that? It should be centralized, shouldn't it? No? That's the, And the other one is the project is finished. Has anybody of you finished the project lately? A system, sorry. You did? Did the company shut down? Was it like they went out of business, or, So anyway, it's interesting, and it's really, really important to kind of live those, be aware and cognizant of those fallacies, because we seem to behave as if they're not there, right? And they always will bite us in the ass. And so why did we do microservices? Kill the empire, right? We wanted to break down the monolith. My only concern about that is that many systems that are going microservices today and doing microservices don't actually need to distribute. Who here does more than 50,000 transactions a second? 2, 3. Yeah, and the rest of you that are building microservices, anybody here doing what, like 1,000 transactions a second? Pretty good, yeah. 500? I don't know what the rest of you do, so I guess it's below that, right? So, do we actually need to break down a monolith if we're doing 100 transactions a second? Is it really worth the effort? Is it do you really have a problem of scale that you actually need to go as far, you know, it is a huge step to take all your code and build your system, a huge overhead. You add latency, you have loads of technology that you need, you know, increase your stack. You need to add monitoring. Monitoring has to be active. You need to introduce all those things. I don't know who was in the CQRS talk earlier, the event sourcing. You need to add all these things in order to make it work as a microservices, right? To deploy a system. So instead of just deploying one thing, put it into production, and when it breaks, go like, okay, I'll fix it. You know, you just go figure what broke and fix it, restart. Now you have 10 of them, or 20, or 100. I have customers that have 1,000 endpoints, thousands of endpoints, yeah? So the first rule of distributed computing is don't distribute. Okay, so do yourself a favor and use the insights, the componentization, sorry, of your business components. Model them correctly and stay away from, you know, creating coupling, but you don't really have to distribute. You only need to distribute once you get to a point where you have high load, seriously high load, seriously high growth, and you are ready to go and scale, okay? This is my small advice. But if you have to break down the monolith, then, you know, this is where we start, right? Everything is like layered. We have very tight coupling on the layers, right? On the vertical, the horizontal aspect, and very loose coupling going that way. At least the initial design is like that, right? Before we start the shortcuts and the cleanups and the refactoring and you know, the developer that comes in after 6 months, or the junior developer comes in after a year, he has a change request and he doesn't understand how this architecture works, and he goes and just does the shortcut, you know, from the UI to the DAL, or from the UI directly to the database. Done that? Looked at a huge piece of code that is impossible to kind of a whole system that impossible to understand, but you just need to add, send an email to the user or mark his email sent. And you're not sure where to go to the business logic, or maybe there's nothing in the DAL, or it's very complicated code to go through the DAL. What do? Go directly to the database. I can do ADO done, and you know, just go and do it. So we end up with something like this. Have you seen this? You know, like big ball of mud, yeah, sounds. So what are we trying to fix when we go to kind of the microservices, service-oriented architecture kind of style? We're trying to vertically slice those pieces of functionality and turn the aspect around and get vertical slices with very tight coupling, yeah, top to bottom, and very loose coupling on the on the horizontal side. So vertical slices, very, very, very coupled. They could go from the smallest unit, I guess, is like bounded context limitation. So you can't distribute it anymore. You can't just break it apart anymore. Does that make sense? The bounded context level? You know, you can, there is a limit of how much you can break things down, but then you get to a point where I can't, you know, I can't do this operation without accessing the database. This is my bounded context. I also need to do 3 more things. They all have to be in the same kind of state machine or stateful operation in order to create an atomic transaction to build this bit of functionality. That is my bounded context. That is the smallest unit of work I can create. One very important thing here is that the database, when you go and do vertical slicing, the database has to also participate in this, this kind of exercise. Yeah? If you don't break down the database, if you don't decouple the database, then all this on the top is useless. It's just, you're just making it worse. You're doing these very loosely coupled things on top, but at the end of the day, and this is I think the most common problem is that your database is going to stop you. Your database is the contention point, yeah? So in this scenario, referential integrity is not an option, yeah? So a lot of people go, oh, that's not a problem, you know. My first system that I built using messaging, taking this pattern, was I built components on top of a relational database, right? And you know what that was worth, right? I just ended up with a big ball of mud, slow, complicated big ball of mud. It was 10 times harder to fix anything. It was a serious mess, yeah? So really, really important to take that into account. So when we're trying to design those kind of systems, we're trying to get components that are loosely coupled and highly encapsulated. And that means that you decouple any dependencies between those components, but they're highly encapsulated, just like object orientation, you know, the first rules of object orientation, Openclosed principle, and so on. The idea is to get to a point where you can build components that are autonomous. They can run by themselves. Those components are doing all the business work that you want to do, all the business functionality you want to do in this one component, and it's highly encapsulated and it's loosely coupled, so it doesn't need data, it doesn't need anything else from outside in order to do its own work. I hope it makes sense. So let's look at kind of do and don'ts, if possible. So as I said earlier, if you don't need to distribute, don't distribute. Just, you know, seriously, you could design a monolith in a componentized way and get the same results. And then, you know, when you need to scale, you can easily tear out stuff, right? Don't use synchronous communication for state-changing operations. And I'm not saying, you know, if you need to read is, you know, obviously a request-response, synchronous communication kind of thing. But when you change state, when you go and you're introducing a stateful operation, so you want to change, create a user, add a user, update something, those should not be done in a synchronous manner, okay? The kind of semantics is fire and forget, yeah? I'm going to send you a message with the data that that is required to do this operation, and I'm not expecting any kind of anything back. Anybody does that today with microservices? 1, 2, 3. Okay, so I presume that the rest of you will do something like a RESTful API, and the API doesn't return 200, it returns data, right? Yes or no? The classic operation is, you know, I create an entity in the database and I return what? The ID, right? Can you see the problem of coupling in this scenario? What happens if I now want to create 10,000 users in 2 seconds? What do I have to do? Magic. You have to batch it or make a magic and have some framework that will automatically fix it for you and hibernate or whatever, and the new stuff, whatever. But to flip that, think if I were just sending a message or invoking that API and just going like, here is a GUID, this is my identifier for the user I want to create, and store that. And I'm not going to wait until it goes to the service layer, the DAL, the database coming back, and all that. I'm not going to wait for that. I'm just doing this one operation, and I'm done. Does that make 10,000 users in 2 seconds, 10,000 inserts in 2 seconds feasible or no? It is, right? Mostly if it's an insert operation, right? It's very quick. I don't do updates, I just do inserts, okay? This also kind of is coupled with the concept of command query separation. Anybody new CQS? No? Great, most of you do. So command query separation is all about separating the channels of which of reading and writing. Okay, so the most basic thing is to say, okay, I have an API to write and an API to read. The API to write is a send only 200 kind of operation if you're using RESTful or REST or whatever. And if you're reading, then you go, it's a request response kind of thing. And the difference is that, for example, the read API could go to a cache, right? It could go to it could just directly go to the database, get some stuff. It could read projections from some read model. Make sense? It's not coupled with the thing that does the updates and the insert, the I/O, the heavy stuff, yeah? Another thing that microservices kind of alludes to is that it needs to be small. How small is your service? Who has 100 lines of code in a service? Microservice. 100. 1,000. You have them. Great. 10,000. Small monoliths. Yeah? So, does it really matter? I mean, is there anything? It depends on, of course, on which language. If you do it in functional, it will be like your 1,000 lines could be done in 100 or whatever. But it doesn't really matter. It's not important. The important thing is your bounded context. The important thing is what is, how small can I make my component to do my unit of work without making it bigger, right? Does that make sense? Another thing that kind of relates to that is the process, right? How many components can I run in a single process? And there is something about microservices that says, no, every microservice needs to run in its own process. Why? Who said that I can't put 5 components, 5 endpoints in one single app domain and run them? If I have 1,000 messages a second, that's fine. There's nothing that stops me from still getting very good performance and everything in one single process. Does that make sense, or? I'd be happy to be challenged, either in questions or later.
I'll answer your question later.
Yep. Good stuff. So do use asynchronous messaging with some kind of queuing mechanism, and whatever it is, it doesn't really matter. Of course, there's like the two styles of architectures, the federated like MSMQ, or Rabbit, which is a kind of broker style. But once you have the queuing mechanism in place, that means that now you can very pass messages around, pass things around in a very synchronous fashion, which is very, very, very decoupled and very easy to scale, very easy to break apart. If you're doing if you have a big team with a big system and you have many teams that work on separate microservices or separate components, they can all be on separate repositories. They can then communicate. You know, there is no need to, once the contract is there, there is no need to actually have the other service available. You're just putting it in a mailbox, yeah? You're just sending an email, send a text to this other component to do some stuff. I just mentioned the CQS. So again, separate read and writes. It's something very basic. You can do it in a monolith. You can do it in any kind of architecture that you build. But once you do that, you get the benefits of, you will change the whole way you approach your business functions, the way you build the system, the way you build the business, the way the user interaction model will change because you're doing this command query separation, because you don't need to wait for responses, because you allow your system to receive commands asynchronously and read from either the same database or a separate database for reads. And I said before again, don't use referential integrity. Once you introduce referential integrity into your database, into your tables, your whatever you put on top is now coupled. It doesn't matter. It's like you are sharing the same resource, and that resource has limitations by the definition of referential integrity, and using GUIDs instead of getting, the auto increment kind of idea means that you can write the same user with the same, or transaction, I guess, to spread it on 5 databases, and they don't need to talk to each other. They don't need to sync. There is no problem with that. Yeah. Also, I hope that makes sense. The other more architectural kind of things is about things that we know already from XP, from object orientation, from the 70s, the 80s, 90s, is be explicit. Yeah. So when you're crafting a method or an API, make sure that this API is saying exactly what you mean to do. Anybody has here update user in the system? Nobody?
Everyone.
Everyone, that is, right? What does update user mean? Modifying the user, right? It's data passing. It's like a crude operation. But what does it mean? What kind of event can I source from it?
User updated.
The user updated, right. So in modern systems, the user entity could have 100 fields, right? Yeah? 100. So you have 100 things that this method can do. It can update the first name, the last name, the email, the citation, the mobile, the address, the country, the address, the zip code, and so on and on, right? It means nothing. There is no way to say that a certain component is doing something. It's just doing loads of things. And obviously, under the hood, this update user method is going to end up with loads of if-else statements, use case, whatever, switching. It's going to be a mess, yeah? It's going to be thousands of lines of code. After a couple of years, it's going to be thousands of lines of code to determine what actually we want to do. Or we delegate it to an Hibernate, right? It will do what to do. It will know. It doesn't matter. Just, you know, just save or update, right? Create or update. Yeah, I don't care. I don't. So if you're not explicit, you're never going to find a way to say all this belongs together because they're all chucked into this one garbage collection. Yeah? And that leads, of course, to single responsibility principle. Anybody writes code in single responsibility principle, using the principle? Quite a lot of hands went up. How many things does your methods do? 10? Okay, let's start with 1. Yeah, no, yeah. 2? Sometimes? 5? Okay, you're very shy, but single responsibility means that you do one thing and then you delegate it to someone else. You raise an event, you send a message to another method, right? Which means that update user is doing 100 things, or the number of fields in the entity, right? But if I say change user phone number, it's one thing that I'm doing, and if I want to raise an event to then, you know, notify risk that, you know, I've changed the user's phone number because he's just moved the operator, maybe he's got no more credit in the other one, whatever, maybe it's fraud, then the single responsibility principles allows me to then add more features, add more behaviors without modifying the old behaviors and still be able to surgically address them, right? So if I want to change the way that, if I want to add a function to when I update the phone number to do one more thing, all I need to do is publish an event or maybe send a command to another component. I hope that makes sense. Keep your verticals slim and autonomous. So don't just break down your system because you think that all that belongs together. Just dump everything into this, don't end up building a monolith, a distributed monolith, yeah? There's a way to define those verticals and break them down, but that introduces a lot of hard work, yeah? Instead of building tables based on our entities, we build tables based on a bounded context. So the user, for example, could end up in 50 different microservices, right? One for the name, one for communication purposes, another bit of the user is going to be in the login area or the authentication, another one for the account, another one for da. So there will be a lot of little fragments of the original user entity in separate tables. Does that make sense? But it will allow you to keep those verticals slim. And it will allow you to decouple your behavior because you are targeting what the actual business operation is rather than the technical, well-designed graph. Yeah? How many of us have started the design by defining database? Some of you? Anybody here did go from the front end? Like just go create a table for a function in the front end? 1 or 2. Okay, try it. Try and define, the user interaction. If a user buys a product and ships and asks, and asks to ship the product over there, what is my bounded context here? All I need is a user ID, right? I don't need anything about the user to create the order, but I do need the user's address to ship it. And I didn't need another to bill it, But all these are fragments. And most of the time, all you need is an identifier to know how to connect those different entities together, the logical entities, but not physical. This is obvious to say that we are building business systems, and of course, us as developers totally disregard this concept, right? Because we want to build systems. We want to build great technology. We want to, sit there coding, building the next coolest thing ever. But at the end of the day, they pay the bill, right? And if we don't build a business, then the system can be thrown away very quickly or become just a huge, huge drain on the business. And eventually we'll lose our work. Of course we don't, we'll jump on to the next contract. But think about it. And one of the obvious things to say is that there are no silver bullets, yeah? Nothing in this industry will solve all your problem. Not any framework, not one pattern. If you go with CQRS, or event sourcing, or messaging, or microservices, or use Redis, or use MongoDB, or use that, nothing will actually solve all your problem. Every time you go into a business problem that you need to solve, you need to use the right tools, yeah? Do you know the saying about, once you have a hammer in the hand, everything looks like a nail? Yeah? So once we have microservices, everything is a microservice, right? And many, many cases it doesn't fit. It's useless, right? If I want to do a synchronous authorization of a credit card, and I have no other problem, from a business perspective, this is the only way to do it. Would you call a microservice to do that? Who would do that? Who would call a microservice, like a charge my credit card microservice? Jesus, you're all saints. What's going on here? It's like, I would do it every day, right? But the reality is that you could, technically speaking, just make this call from your UI directly to your third party, and yes, just send a message over to the backend to say that you charged it, right? There's no need to build a whole stack of things in order to charge a credit card. There might be need to relating to the order to do more things after that, but that's unrelated to the synchronous operations that we need to do, and there's nothing wrong with just calling the web service, their web service, directly from the UI and getting the authorization code and continue to work, right? But if you can avoid it and really do it asynchronously, then yes, go ahead and send a message to the backend and continue your workflow. And do UI composition. Anybody know what UI composition is? So when you're trying to build a UI on top of your microservices, what do you do? Modularize, okay. How do I get all these little services into a one thing? How do I get a product and their recommendations and my ads and my branding, and how do I get that all into one page? All separate microservices, right? What do you do?
How do you compose on the web server, or you compose in the UI?
Correct. So you either compose it on the web server, or there's no one way about it, yeah? You can compose it in different, but at the end of the day, you have to compose, right? You have to have all these little bits composed into something that a UI, a user can interact with. Make sense? And these are the things we really want to forget about, right? Monitoring. Anybody here likes to drive 200 kilometers an hour in the dark with the lights off? On the motorway, you do. Can I join you? Do you have insurance? Yeah. No, it's exciting. There's no doubt about it. But the likelihood you hit a wall is very high, right? Mostly in the higher speed. So monitoring, you have to turn your lights on. In the monoliths, we really just did the very basic. We kind of kept it, just, is the system alive? Can a user log in? Yeah, cool, system's alive, that's it, that's enough. When you distribute stuff, those systems are meant to be redundant, right? You should be able to go and turn off half your microservices and the system will still work, right? Monitoring, very, very important. I don't need to say about automating, automate everything. anything and everything that you can automate. And use packaging. Anybody is using packaging here for like the dependencies between, you know, your shared contracts and stuff, yeah? That's great. It's really, really, really handy to do that, because once you have hard dependencies and hard references, things go bad, because somebody is going to make a change to your thing just before you're going to production, right? So packaging is really... So to summarize, avoid all dimensions of coupling and think about those dimensions. When you're starting to build something, think about what's going to happen when you want to change it, and what are you going to drag into that change. Avoid a synchronous communication between components and microservices. All these here in the room that are using, that have microservices call each other, please, please, please think, why are you doing it? Because that means if you're calling another microservices and it's not there, you're sitting like a dead duck, right? If it makes you fail, then you're going to fail, you know, you're going to cause the whole system to slowly fail, right? If you're exchanging data between microservices, you're leaking your abstractions, right? Your bounded context is all over the place, okay? Don't share your data, coming to that, and use read models to share data in read-only mode, yeah? So you're able to, you know, if you need to create an invoice, what do? For an invoice, you need to, you know, there are like 7 microservices, or if not 70, that are involved. Then you need the order, the customer, you need all, you know, the whole shebang. So if you can make that data available in a read model, so in a read-only view, then that could be shared, and it's nothing to, you don't have to go looking for where the data is. And if you're on .NET, try NServiceBus. This is a shameless plugging. And also this, if you're interested in microservice design, there's a link here for some of Udi Dahan's online tutorials. There's a nice blog post, the ebook again, and the link to the course, and that's it. You want sorry, anybody want to take a picture of that? There's, if you just fire and forget your state-changing operations, how can you let the user know he was successfully saved? You don't. You cheat. You go to, you send a message over. It is durable. The message will get to the backend in, you know, in eventually, right? You can store. You can cache the fact that you have created the user account, yeah. And when you show it to the user, you show it. You show him that he's pending, okay? And when the backend finishes its operation, whether it's a millisecond, a second, a day later, you update the cache. Who asked that? Anonymous? Does that make sense? It's something, this is the whole thing you need to deal with eventual consistency, yeah? So you have to kind of build something that will compensate for that. So whether it's the user behavior or the, you know, how many of you have gone to Amazon and got an email after a day or after a couple of hours that the credit card failed? They couldn't charge the credit card. Yeah? It's the same idea, right? When you clicked the buy, it said, yeah, thank you very much. You got an email, successful, everything's cool, right? 10 minutes later, no, the card doesn't work, right? Okay? The other question is, would you go for distributed architecture purely in sake of scaling the complexity rather than scaling the load? Absolutely, but I wouldn't, and that was my point earlier, I would go to a distributed architecture by componentizing stuff, but I would avoid physically distributing the code, yeah? So I would deploy everything to a single or a couple of components, yeah? a couple of domains and have them run in the same context. There is nothing, you could use, instead of messaging, you could use eventing. So if you're, I don't know about Java, I'm a .NET guy. So in .NET, you could just raise an event, right, in the same app domain, and that will do the same idea as publish, subscribe. If you use CQS in a monolith, you could still do the same concept. There's nothing stopping you. So I would definitely say that, borrow or lend those concepts in order to build a more maintainable, loosely coupled system that potentially could scale, because all you need to do is then take this component that's your bottleneck and move it outside to a separate process, yeah? I hope that makes, who asked that? Thanks. Yeah.
So I'll pick up the point you made earlier, and this is the point you just made there about being able to essentially deploy to a single process using APIs.
Mm-hmm. Yeah.
And my concern on that is that, once upon a time we talked about the 4 tenets of SOA, to which we said services are autonomous.
Yeah.
And one of the ideas is that we can independently deploy our services.
Absolutely. Yeah.
If I've got multiple app units in the same process, I can't independently deploy.
Correct.
That's why I say 12-factor apps, which say use the process model, right?
Yeah.
It makes it actually what I'm getting for is a process, because then I can deploy it entirely separately from everything else.
Yeah.
My concern with this model of saying deploy your multiple services into the same process is that
It goes against that. So the question was, or the remark, I guess, was that, if you deploy, one of the basic tenets of SOA is autonomy, and one of the things that we benefit from distribution is the fact that we can deploy separate components in different times, correct? And so the question was, how does that how does that align, or is it not orthogonal to the idea of putting everything in a single process? So my thing, what I'm trying to say by saying put it in a single process is, if you don't need that deployment, the separate deployment, the separate stages, the autonomy to that level, you could reduce your, greatly reduce your complexity by deploying everything in a single process or a couple of bigger processes. Does that make sense?
Yeah, it does, but then the follow-up one to that would be that you talked about the reasons for distribution depending on scale, but the 2 other reasons that follow up in each of that regard. One is scaling the development team. Someone can have multiple teams deploying independently, and they're essentially wanting to deploy separate processes, and that
Absolutely.
the same route.
Yeah.
The other one is the kind of 12-factor app notion. If I want to be able to scale portions of my app independent of other portions, that was probably leads to your point about the very high scale, but even the lower scales of workers, that can be quite helpful.
It is, yeah. Again, it's a balance. It's a balancing act. You have to take it. What I'm trying to say, of course, I'm aggravating here, yeah, because I'm saying like, don't do it, don't do it, don't do it, and then I say, yeah, but if you want to do it, you need to do that and all that. So it's like, yes, if you can get the benefits from distribution, there are many, many benefits, and as rightfully was commented here, but I'm just saying, like, weigh it against the price that you pay for doing it. If you're doing multiple teams on multiple locations, different cycles of deployment and all that, then definitely you need to distribute, and definitely you need to have autonomous components that are coupled to those teams and their sprint cycles and so on. I hope that.
I recognize that you are raising the less considered point, which I think is valuable.
Mm.
If people don't look at that option.
At least look at the option. At least be pragmatic about what you're. Monads look great thing to use. Can it happen, or is that the new legacy? I have no idea. Sorry, I don't have enough knowledge in monads to comment on that. Any other questions?
Yeah. You said that no matter what best practice you try to use, the application being deployed leads to big bottom line anyway, and this is especially when many junior members of the team involved to do shortcuts to fix the bug that go from UI to the database. And in my view, I'm completely with Ian on this. There's like splitting, componentizing by physical boundaries actually helps in this case. So I see the with a contradiction saying, I tried this and it doesn't work, and say it still don't distribute. It doesn't really.
So again, I'm trying to invoke the thought in you rather than tell you what to do, okay? This is, I'm trying to, as we just said, you know, think before you distribute and make sure that you're doing it for the right reasons and do it correctly, okay? And not, you know, it's very cool to say, I'm doing microservices, right? And the whole architecture is event sourcing now, yeah? So I'm doing the whole system event sourcing, and it's like, hold on, why do you need to do event sourcing on a non-collaborative domain? What's your arguments? And you say, do the 5 whys and say, this is why I'm doing it. Cool, excellent. Do it, think, you know, but don't just go automatically and think that's going to solve all your problems, because it won't. If you do distributed computing and you do your boundaries wrong, you're in a world of pain. Anybody, I failed with that at least once, yeah? It's a nightmare. I don't know, you know, I used to get tummy aches thinking of going to work in the morning. It was like, you know, what are we going to deal with today? You know, what kind of horror is, you know, we're going to find? Or looking at the horizon of 9 months of refactoring, right?
I call it pain-driven design.
Pain-driven design. Okay, if there's no other questions, then thank you very much.